Hello. So Bjorn has already introduced me, so you can just look at that slide briefly. But he doesn't tell you the other things which I am the key contributor to. Because this is a story about life of a label, and Julius has already touched on the more interesting aspects of labels, because I have a confession to make. I am the guy who's responsible for relabeling existing, and I had to fight to make relabeling existing. Now, before you get out the torches and pitchforks, let me explain, please. Give me a chance. Because if we're going to talk about labels, we have to start off with instrumentation labels. And these are the labels you put in your code, because direct instrumentation is best instrumentation. Because you want to distinguish get versus post if you're taking it at a technical level, or maybe Visa versus MasterCard if you're checking which payment method doesn't work. These could be from business logic, like Visa versus MasterCard, very business logic. They could be from a random library, like some authentication middleware is saying, hey, is this a get or a post I'm authenticating? And you add them in your code. So here's a Python example. You add these bits and you can get your method and endpoint for HTTP. Nice, simple example, and it looks like this in the text format. And great. So you've gone and instrumented your system. Very well done. Congratulations. That's what you're meant to do. But how are you going to get this data back into Prometheus? Because you've got a little bit of a problem. Now, if you had a push system, your push system, you have to instead tell it where the monitoring system is. With a pull system, you need the monitoring system to know where things are, so it's the reverse problem. And you need a way to find your targets. And as was pointed out by both ShuttleCloud and DigitalOcean, a manually edited file doesn't scale particularly well. So we need service discovery to go find things automatically. And we have many, many types of service discovery. Files, EC2, console, Kubernetes, EC2, DNS, Azure, GCE is still in code review, and 2 Zookeeper ones. File SD reads off disk. If you aren't using something we support, you can use that. Otherwise, we get stuff over the network and we get a list of all your machines. But then all I have is a list of machines. Okay, let's say all instances from an EC2 region. And that's nice if I just want to hit port 9100, monitor the node exporter, pull in those 400, 500, 600 metrics, depending on how many disks you have. But you kind of want to, if you're talking about services on top of that, you want to say, no, I want the MySQLs here, the Apaches here, the Cassandras there. So you need to select which machines to scrape. And here's where we come into the problem as to why relabeling exists. Different organizations do it differently. Okay, some people might be using the name tag on EC2, other VPC IDs. Others, they might have some naming scheme they have on top of that. And this sort of thing is rarely consistent within a team or an organization, right? Everyone does it differently. It's possible even a single team, and I've been on teams which had 5 different conventions for how you name things. And this is normal, because what we're doing here is we're dealing with the complexities of the real world, and we need to map those back into Prometheus. And in fact, the other thing is that everyone thinks that their way is the only way. And this is actually a continuous problem for us when we get code reviews for new service discovery mechanisms. Because almost every single one of them, like I wrote one that didn't make this mistake, but there's a few others that are okay. But most of them have hard-coded assumptions about how their system works that they want to put inside Prometheus. And it's like, yes, that will work for you. We've got other users as well, so this is an actual just perception thing we'll have. So as Julius mentioned earlier, we could have had a config file and an option for, hey, here's the SoundCloud way v2, SoundCloud way v3.4 for that other team who's doing something weird, and all these interaction options and so on. But that would have been insanity very quickly. Even just probably the pure SoundCloud options would have quickly become incomprehensible. You then add the other several hundred companies we have and all their variants. Good luck with that. Instead, we have relabeling. Because the thing is, what we want to allow is that people have different views of the world, and we want to take their view of the world and translate that into Prometheus metrics. So the exact same node exporter that might be running on one machine, if you could have 3 different Prometheuses, all different views. Like if I'm the operations team, I know about EU West 1 and AZ equals A. And that's how I think of the world. But as some other team, what the hell is an EU West 1? It's Ireland, because it is, and that's our production environment. And that's their view of the world. Whereas someone else is like, actually, I don't care about any of this stuff. I'm trying to debug a weird network problem that's one of those 350 net stat metrics we have. I just want everything so I can see where that's happening so I can go and debug it. So they don't care about any of this stuff. They just like, give me everything. Bring it to me. So you want to allow all these views of the world to exist. In fact, you can do this all inside one Prometheus. Generally not a good idea for sanity reasons. So that comes then to what is relabeling. Relabeling is ways we can take in metadata about a target. A target is something we scrape. And based on that, select which ones to scrape. We also normally give you some target labels. So by default, it'll just have a name, which is the address label and the instance label. So how do we deal with the fact that all these systems like EC2 and Kubernetes have very different metadata? How do we give people a way to work with this, especially as they might have their own structure inside that? And the answer is we take the standard Unix fallback. We have a pile of data that's completely unstructured. We have no idea what's going on with it. We can't make any assumptions. Let's have two problems. Sorry, let's have regexes. What we do is that you say, hey, meta console tags, like if you've got console tags, that's how you get them from. Regex production, keep that thing. So we're saying here, every one of my production nodes, I want to monitor those, everything else, ignore. And there's actually a little detail here because we have lots of different metadata. If something is a dictionary or a map or a hash, it's pretty obvious we can directly map that to a label like meta console, my label name, and then the value. If something's an array like console tags, how do we expose that? The answer is we chuck it all in a list separated by commas. It then turns out lots of people who aren't extremely experienced with regular expressions aren't aware of the edge cases of that, and that it's just joined by commas. It means the first one doesn't have a comma in front of it, and the last one doesn't have a comma at the end of it. And people don't know how to correctly handle that. So what we actually do is we put a comma at the front and the end as well. Because that means then that you can do this. And this works in all cases. You do the dot star in each end. And this is also why Prometheus regexes are anchored. Because it also turns out that lots of people don't know how regexes work and don't realize that, for example, if you search for production without the commas, without the stars, it will actually also match not production. Because that matches. So we actually do this as well to basically, because people keep on making this mistake, at least this way, the first time round, they'll get it right because it won't work otherwise, and they don't make the other mistakes. So that's why we actually switched everything to being fully anchored in Prometheus, because people were unknowingly making this mistake. And it works out. So there are two relabel actions. The simple ones to start off with are keep and drop. If the regex matches with keep, we keep on going. If not, we stop processing. Drop is the other way around. It's just for convenience you have both of them because inverting regexes, particularly with RE2, is not nice. So they're just the inverse of each other. But what happens if there's more than one label you want to work on? Maybe there's two EC2 tags, two Kubernetes tags, or you want to use the service name and a console tag. So the sources labels, as you might hint by the S on labels, is a list. So you actually specify everything you want, and we'll, as with arrays, concatenate them together with a semicolon. And then you can throw regexes against it. Yeah, you're sensing a pattern here. And you can change the separator. Int and general thing with Prometheus, empty labels is the same as not having a label. So you'll get just a space if something's missing, because otherwise you'd have to deal with variable numbers of commas, which will be messy if two consecutive ones were empty. And the other thing is that it is relabel configs, so that's a list as well. So every single rule is processed, every single action from top to bottom, and it processes them all unless it hits a keep or a drop, which makes it stop. So they are all always at least attempt to apply. So you get as many as you want. As the Julius example showed, it was about 10. Okay, so here's what we've got so far. We've got service discovery. It's producing metadata. We can use regexes with keep and drop to choose what to scrape. But Prometheus labels are one of the two key features of Prometheus, because you've got the labels and you've got the query language. Those are the killer features. Wouldn't it be nice to have some of that metadata, like this is production or dev or whatnot, in the target labels? like the labels that we're going to add as we scrape. That would be kind of nice. And this brings us to munging labels, and this is where people normally start to get confused when we're talking about relabeling. The core of relabeling is the replace action, or the substitution action you can think of. We take the source labels, they're all catenated together, chuck a regex at it. If it matches, then we put the output in the target label, whatever the substitution is. Nice, simple idea. Okay, it's just doing a regex against some labels and if it matches, chucking the output in another label. Nice, simple. And the complication is, of course, the real world. Because you have to think out, actually, how do my things work? And then you just have to actually write that down for the first time rather than just keeping it in your head and working by intuition. That's where things always get fun. So let's take an example. Let's say we want to take the EC2 name tag. That's the one that displays in the UI by default. We're going to have, source labels meta EC2 tag name. The regex is .star and it's a capture group. So we're going to capture that entire thing. The replacement is, the entire thing, the first matching group. And the target label is job, let's say. So that will end up with the job label of that. So it's just basically just doing a straight copy from the EC tag name to the job label. Seems simple, right? Of course, this is also kind of verbose. And because it's so common to want to copy labels around, these previous settings are all defaults. So, what should I do? So, .star in brackets is the default for regex. Action, replace, is the default. Replacement is that as well. So you can also actually use this to set a label because you just set the replacement to the value you want, the target label to what you want. Regex.star will match the empty list always, and you can use that to set labels. Handy trick. And the other thing as well, and I wrote a blog post on this recently, that the service discovery will always return an address label. And that's the thing it's going to attempt to talk to, and that's a host port. If no instance label is present at the end, because instance is one of the special two labels, the other is job, which we always want to try and set, we'll just default it to the value of address. So this is why your instance label normally ends up as a host port. But because there's this separation between address and instance, you can actually have them as different things. So if you're using the server set or the nerve discovery, you could have the address be, the address, because we kind of need to talk to it. And then the instance label be a zookeeper path, or anything else that makes sense to you. And because of this, there's no need to add additional alias or host labels or whatnot. You just use the instance label for what some unique name for that instance is. Because every label you add to a target is kind of a liability, because it means that when you're writing rules later, people have to be aware of that. So you have to be limited in what ones you do. Or as I put it, target labels are for life, not just for Christmas. There's lots of other settings you can relabel, like those examples are actually in the Kubernetes one, because the Kubernetes one is someone who went all out with using relabeling. Usual examples are simpler. There is params as well. So how many people here have used the black box or SNMP exporter? Okay, so we've got maybe 20% of people. How many of you understand that block of relabel actions? Okay, about half of that group. That's actually more than I thought. So they're actually inverting things, and I'll discuss this more in my talk tomorrow. We're passing in URL parameters to tell us where the target is, and then switching in the address label. So you start off with an address label of what you actually want to probe, then changing that to a URL parameter, and then putting in the black box exporter as that, yeah. If you go and read that now after this talk, you should understand better what it's doing. And you'll understand just how crazy a person I am that I came up with that. But yeah. And there's also two other label actions. Label map just copies things around. So you can imagine if you decided, like with EC2 tags and Kubernetes labels, and said, hey, anything prefixed with this, we'll copy it over. And that's what that does, because you might know all of those a priori. And hashmod is actually used for sharding. Unless you're sharding, one of the 4 people in the room doing that, don't use it. Another question is, because we have these two different types of labels, we have these labels on the target, and we have these labels coming from instrumentation. What happens if someone, is silly and decides to have a label called instance? So the answer is there's a general principle in Prometheus that the person running the Prometheus is not necessarily the person running the service, because we've got the whole horizontal monitoring idea. And you don't want to be in a situation where someone is exporting stuff that breaks your Prometheus, right? So what wins is the target label always wins, right? Because then we always know that the instance label is the one I selected, not the one that the user is exporting. And what we do then with the original instance label is we call it exported underscore instance, so it's still there so you can access it. So, but generally, if you are ever exporting labels, try to avoid ones that, people are likely to have as target labels. You can turn this off with honor labels equals true, which would use the push gateway, because sometimes you want to do that. Because, like, for example, if you are having cluster level stats in the push gateway, which is what it's meant for, there is no instance label because there's no instance. So you can just actually export an empty instance label with honor labels equals true, it'll have no instance label. There's another type of relabel configs, because we have several of them. We're up to 3 so far, 4 soon, hopefully. Because sometimes, things get a little overloaded, and someone starts, deciding to break out a metric by email address, which aside from being PII, is massive. So what you need to do is drop that stuff on the floor. So metric label configs apply after the scrape, before the data is put inside the database. And you can just say, hey, anything that matches my big metric by email, drop. So that's a tactical solution until you can go find that developer and have a chat about cardinality. A polite chat. It also sometimes is things like CAdvisor and so on that they don't know about the structure of Docker. So it's a way you can mess around with those labels because it's not technically practical. But generally, metric relabel configs are a tactical solution until you can fix things properly. And something else to be aware of is up does not come from the scrape. It actually always has the target labels. So metric label configs never apply for up. And in general, if you ever wonder why a relabel config isn't working, it's because it should be a metric relabel config instead. So that's a common misunderstanding people have. And as other place then, we've got these labels. They're coming from instrumentation. They're going into Prometheus. And they're going out to alerts. So we have an alert here, example using again my request total, less than 10, not the best alert ever. And we've adding here a severity label in addition to the endpoint and method labels that were coming from the original instrumentation example. So all these labels are coming together. And there's also external labels and alert relabeling, which will be out in the next release. So you can actually adjust alerts before we send them to the alert manager. So you can drop alerts you don't want. So like maybe you had a severity equals info that you were just using for dashboarding or something and you don't want to load the alert manager for. And also just distinguishing different Prometheus servers. So external labels is when we're talking out to remote storage or talking out to the alert manager, these will be added if they're not set. So the idea is if you have multiple Prometheus servers, each of these should be unique. So you can tell, oh, right, no, that's the production Prometheus server, that's the dev Prometheus server, that's automatically attached, and we can use it in the alert manager. Because as with everything else in Prometheus, the alert manager works on labels, and labels are key. So you can have a label of like team equals billing and team equals API, and then route based on those, and say, right, this subtree over here is the rules for the billing team. This one's the API team, and they can have different ways of doing things. Maybe one uses Slack and the other uses HipChat. And they can, each of them, choose themselves how they want that routed. And the other thing we do is grouping, which is actually really handy. Because there's other monitoring systems that, every time there's an alert, you're getting an email. Which means that you can get many emails, which you will then dutifully ignore as an intelligent person realizing they're spam. With Prometheus, we're grouping things by label. So you might say, hey, I want to group these by alert name and by data center. Because, well, if I lose an entire rack, I can only get then one alert telling me which machines are down. Or maybe by alert name because, hey, I've got a propagation delay alert. It tends to happen in all the data centers at the same time because there's a network outage. And it's, once again, only one alert rather than 20. And the final thing we have for labels in the alert manager is silences. So you can pre-create things saying, that data center, there's about to be a power outage there. I'm going to silence all of it and not get those alerts, not to get those notifications. Because it's important that, if you get any notification about alert, you actually care about it. Because if you are getting lots of notifications that you're ignoring, you become fatigued and will miss the important ones. And burn out and leave and get another job where the same thing happens. Which kind of sucks. So to summarize, the instrumentation labels, they come from the application. The service discovery then creates targets. We relabel those to figure out what we're actually scraping, pull those in, and add the target labels. Then you do the metric label configs. We apply those to the scraped time series. Those go into Prometheus. Then we get alerts, run those against those, add additional labels on top of what the alert expression gave, send them out to the alert manager, and then the alert manager uses them for basically everything it does. And that's how labels are threaded through the Prometheus stack as it stands. And here's some resources. So there's the main docs on how to configure. This stuff. There's the label flow, just some nice pictures explaining how it works. There's some best practices there from a few weeks ago, as well as the general Rust reception blog and an email address. So, questions?
So, more questions? You're doing that on purpose.
I was really curious about the performance implications of labels. We use them quite a bit, but I really don't know how that's affecting the performance of our server.
Okay, so performance implications of labels. If you're talking on the ingestion path, they use some bandwidth. If you're talking on querying, we're working on that. So at the moment, we recently added a heuristic to make it a little more efficient. But ultimately, we need a proper search engine to figure out which ones to pull in, because we should, be basically estimating the cardinality and selecting things appropriately. Like we need a query planner, basically, just for labels. But generally, the labels are kind of cheap. The real thing with labels more is thinking about the semantics of them and cardinality, because the question isn't so much the labels effect on Prometheus, but how many time series is that creating? Because you can imagine if you have 1 million time series because you've broken out by email address, that's like, we figure at the moment Prometheus can handle about 10 million metrics per server. There's a limit somewhere around there. So if 10% of your resources are gone on just this single time series, that's not a good use of resources. And you have to balance, okay, how much operational cost is it worth me having to go using sharding now just to deal with this massive metric, or I could stop doing that and use logs for it instead. And it's that sort of trade-off you have to make. Is it worth my time, scaling this up and having to nurse and feed this server, or we just decide, actually, that metric isn't worth it. Let's just scale down the cardinality. So that's more where the question about labels is.
Hey, a question based on, I guess, group substitution. So I'm thinking, let's say I have a range of IP addresses and I want to show, instead of the IP address list, that it's in this country. Is there a way to do that with labels?
So you want to do like geo lookups?
That is one example, but let's say that I have a cluster of servers that's in some region and I want to identify them by the region, but the list of server IP addresses and regions changes over time.
Yeah, so if you're doing something that custom, that's not going to go in Prometheus itself. What you're going to do is write a little bit of code that will generate that from whatever database you're getting this stuff from and use the file SD. So basically write out a JSON or YAML file with everything. Because everywhere in Prometheus, we know we cannot support everything. So at every level, we have a generic interface to let you do whatever weird stuff you want to do. Because we can't support this internally. This is why the node exporter has a text file collector. Why we have scraping generally, the webhook, generic webhook notifier on the alert manager, and hopefully some stuff in future around remote storage. It's all like, here's a generic interface. Have fun, because we want to keep Prometheus scoped very carefully. Well, yeah, if you know the regexes and want to do it via regexes, you can, but you're probably better off just writing something, pulling this from whatever database this is coming from.
Okay, more questions? Okay, wait a few more seconds. All right, so the lunch is catered and it will happen at